What's up guys, in this tutorial I will be showing you how to connect 3 ultrasonic sensors to the Raspberry Pi so that you measure distance using all 3 of them. A quick thing to keep in mind is that this video is a series for my 2 previous videos. The first video where I've shown the steps to connect 1 ultrasonic sensor to the Raspberry Pi and measure distance, and the second video where I've shown how to connect 2 ultrasonic sensors to the Raspberry Pi and measure distance. If you have not watched them, I strongly recommend that you watch them to be able to follow along. So the first thing that I'll be talking about are the GPIO pins of the Raspberry Pi. It happens that we only have 2 pins that provide 5 volts, pin number 2 and pin number 4. And we've already used them. We've used the first one when connecting our first ultrasonic sensor, and we've used our pin number 4 when connecting the second ultrasonic sensor. So to tackle this problem, something that we can do is to connect one of our GPIO pins. So I'll just choose pin number 4. So as I've mentioned, we've already used pin number 2 for our first ultrasonic sensor and pin number 4 for our second ultrasonic sensor. So we don't have any pins left to connect our third ultrasonic sensor. So the way that I will be tackling this problem is by using pin number 2 to supply my first ultrasonic sensor and my second ultrasonic sensor by connecting the VCC of my second ultrasonic sensor in the same railway that has pin number 2 connected, since we know that voltage in parallel is the same. And by doing so, I'll be able to free pin number 4 and by using this breadboard, I'll be showing you how to tackle the problem of 2 5-volt pins coming from the Raspberry Pi supplying only our first 2 ultrasonic sensors. To be able to supply multiple ultrasonic sensors using the 2 5 pins voltage, we have to be a bit creative. So what we have to do is connected them in parallel. So what I mean by that is, if you remember, our first ultrasonic sensors VCC was connected right here, and after we connected our pin number 2 coming from the Raspberry Pi over here, and the same thing happened with our second ultrasonic sensor. We connected our first ultrasonic sensors VCC right over here, and then we connected pin number 4 over here. But to be able to power multiple sensors, what we can do is that we can unplug the VCC coming from the ultrasonic sensor and we can plug it right over here. Right over here. Since this whole thing is connected in parallel, like this whole thing, and we know that voltage in parallel is the same, so the voltage that is being supplied to our first ultrasonic sensor would be equal to the voltage that is being supplied to our second ultrasonic sensor, and continue. Following the explanation that voltage in parallel is the same, I disconnected my second ultrasonic sensors VCC and I plugged it in to my first ultrasonics. Now that I've clarified that, let's go ahead and connect our third ultrasonic sensor to the Raspberry Pi. So the first thing that I'll be doing is try and see which pins from the Raspberry Pi will be connecting to the breadboard and ultrasonic sensor. So the pins that I'll be using are pin 33, pin 35, pin 39 for ground, and I'll be using pin number 4 for voltage. Based on the diagram I've shown you, I've connected the female to male jumper wires to the Raspberry Pi pins. I've connected pin 39, pin 35, pin 33, and And I'll be unplugging pin number 4 from our second ultrasonic sensor, and I will be connecting it to the new breadboard. So this is my pin number 4 and I've disconnected it. So I'll be quickly going over the steps that I followed to connect my third ultrasonic sensors, because I've already done them when connecting my first ultrasonic sensor and second ultrasonic sensor. So I figured it'll just be repeating myself if I show you doing it the third time. So the ground from the ultrasonic sensor is connected to the negative railway, and VCC is connected to the positive railway of the breadboard. And once I've done that, I've connected pin number 39 to my negative railway of the breadboard, and I've connected pin number 2, which is the 5 volts, to the positive railway of the breadboard. And once I've done that, I plugged in trig to a blank rail, and I've connected pin 33 to the same rail that had trig. And once I've done that, I've connected echo to a blank rail, and I've connected echo to another rail using a 1 kilo ohm resistor. So once you've connected the 1 kilo ohm resistor to another rail, connect it to the ground using a 2 kilo ohm resistor, and make sure to leave space in between so that you plug in pin 33 from the Raspberry Pi. And I accidentally mentioned to connect trig with pin 33, I mean pin 35. And if you want more details on how to connect a single ultrasonic sensor, you can refer to the previous video. Now that we are done connecting 3 of the ultrasonic sensors to the Raspberry Pi, I've placed an object in front of the ultrasonic sensors. And now we can go ahead and run the code. I'll show you the code after running it just to make sure that it works perfectly. So the first ultrasonic sensor measured a distance of 272.99, the second one measured 2167.42 centimeters, and the third one measured 268.14 centimeters, which means all our sensors are working perfectly. So now I'm just going to open the code. So this is the code that I've used to measure the distance from 3 of my ultrasonic sensors. If you put this code as exactly as it is, it will work perfectly. I'm just going to scroll a bit down so that you're able to see the whole thing. And that's about it. I hope you have benefited from this video. Make sure to leave a thumbs up, and I'll see you next time.